And we will be sharing this. Oh, do we have a question already? Somebody has their hand up. Is he allowed to talk? Is there a question? Jimin? See that your hand is up. Jimin.
Sorry.
Yeah.
Yeah, sorry, I don't have a question at the moment.
Okay.
I'm really excited to hear about it. Thank you.
You're welcome. All right. Okay, cool, Mike. Take it away.
All right, so welcome everybody to Cloud Native Meetup at Scale for this week. This week, very, very excited, one, to host, but also to participate and listen to the two amazing presenters. One's going to be giving a community update on Dapper, distributed application runtime, and the other, Todd Ekenstam from Intuit, is going to talk to us about Kubernetes at scale at Intuit. And let's go ahead and get started. So I want to make sure that we give adequate introductions to everybody and make this exciting. So Yaron Schneider is founder, CTO at Diagrid, and he is one of the, if not starting engineers or founding engineers of both the distributed application runtime Dapper and one of my favorite projects as well, Kata, Kubernetes event-driven autoscaler. He was also one of the lead architects for the Azure container apps, serverless containers, cloud services from Azure. And so with no further ado, Yaron, take it away from a community update perspective.
Yeah, thanks, Mike. Let me share my screen and let me know when you can see it. The most repeated phrase in 2020 to 2022.
Yeah, we can see it. We're good.
All right, awesome. So today we'll be talking about Dapper and a bunch of updates that we maintainers want to give to the community. But maybe before we dive into that, let's talk for a sec about what Dapper is, because not might everyone know what the project is about. So essentially, Dapper is just a bunch of APIs. And these APIs are developer facing. So if you're a developer writing a distributed application, either on Kubernetes or on other type of computing infrastructure, it can be VMs or even another orchestrator, you need to still deal with things like how do I discover and talk reliably to other services? How do I handle distributed state when I have multiple replicas trying to change the same state record? How do I create event-driven architectures? How do I do pub/sub? What the hell are consumer groups? How do I trigger my applications when events are coming in, and how do I do that safely and reliably? And then how do I have end-to-end observability between all of my different services? And this is especially true with today's microservices architectures, where people are having more and more compute units spread out. So observability becomes really important, not just for point-to-point communication, but also when you're receiving events from outside of your service layer. So for example, if you have an event coming in from like a Twitter API or Kafka, and then that event goes in through a service-to-service call, you basically want to have like a holistic graph that shows you all of your calling parties in that communication pattern. And then developers also need to get hold of secrets. So you might be running in multiple or on multiple compute environments, and getting a hold of secrets from multiple secret stores. It might be Azure Key Vault or AWS KMS or HashiCorp Vault. So Dapper offers an API, a really consistent API for developers to basically get these secrets from all of these stores in a really secured way. And then configuration allows developers to get notified whenever a configuration item that's used by their app changes. So developers have these APIs that they can access using HTTP or gRPC, and that really enables developers writing services in literally every language that just knows HTTP to talk to Dapper and make use of its APIs. And like I mentioned earlier, Dapper runs especially well on Kubernetes. It runs on most of the Kubernetes distributions that you'll see in the major clouds. OpenShift included, but it'll also run on just plain virtual machines. And we have seen companies taking Dapper all the way to the edge and running it there. And the way that Dapper is accessed is via a sidecar pattern, which means you have your app, then you have the Dapper sidecar, and each app basically talks to its own sidecar. And that's pretty good for lifecycle and resource management and governance of compute. So let's talk a little bit about some of the Dapper community momentum that we've been seeing. I think from the get-go, we've seen a tremendous participation from the developer community, especially from enterprise developers, and not just or not necessarily only operators that deal with how things run, but developers who are tasked with writing these apps and who are concerned with how do these apps actually distribute states and communicate with one another in a microservices architecture. So we have about 1,700 contributors today. We've seen 90 community components. So when we launched Dapper in 2019, the number of components that it had were around 7 or 8, and all of the rest were totally contributed by the community. Us maintainers didn't write a single component, really. And components are really the backbone of Dapper. So a component might be something like AWS SQS or any form of database or cache or secret store that you can then hook up to Dapper and just use its APIs and then configure the component in the background. So the components are really the backbone of it. And that's really where the community really came together and contributed amazing components to Dapper. And we're seeing today about 2 million Docker Hub monthly pulls, which is amazing, I think. And our Discord server, if you haven't joined it yet, I highly recommend that you do so, not just because you talk about Dapper there, but because like our Discord server became this place where developers can really get together and talk about anything, any sort of concern that they have regarding their apps or architecture. And it's not only Dapper, but it's really this place where people collaborate with one another. And it's really awesome to see. We have about 2,000 monthly docs views, which is great, distinct views. And we've been seeing lots of organizations contribute to the project, really from the get-go, HashiCorp, Microsoft, obviously, Intel, Alibaba Cloud. Today, Dapper is governed by several companies that make up its steering committee. And these are Intel, Microsoft, Alibaba Cloud, and my own company, Digrid. And we basically form the Dapper steering committee. We basically ensure that the technical vision of the project is what it needs to be and that it goes where we want it to go. But then there is a multitude of other organizations which are also contributing to the project. And this chart here on the top right is a little bit outdated. Like I said, we've been seeing 1,700 contributors today. But we're seeing this graph just grow really nicely, and that's really amazing. And in November 2021, Dapper was accepted into the CNCF as an incubating project, and we will see you at KubeCon in a few maintainer track sessions, I hope. If you're attending it, please make sure that you see what we have to offer there, because I think we'll be talking about some really interesting things.
Real quick, Yaron,
yeah.
I wanted to ask, so you mentioned Intel's part of as a contributing organization.
Yeah.
Todd, do you have any thoughts on that from Intel's perspective, how you're looking at the Dapper project?
Oh, but that's Intel, not Intuit. So, but Intuit is also interested in Dapper. We're not currently using it.
Whoops, I'm sorry. Wrong company.
Yeah, okay. That's okay. That's okay.
Got it.
But there was a question in the Q&A box.
Yeah, there is a question. And we've got a little bit of time. At 1:15, we're going to transition. So, Yaron, how does Dapper differ from traditional service meshes such as Istio and Linkerd?
Yeah, so if we go all the way to this slide, service meshes are concerned with service-to-service invocation. That's the very left box here, and that's it. Service meshes do not give you APIs to manage state or APIs to create event-driven architectures, nor do they invoke your app whenever different systems change. And they don't have these APIs that are really developer facing. So they explicitly focus on network level interception of communications. And for these types of point-to-point calls, they give you observability and MTLS. So Dapper does that, but it also gives you state management APIs, PubSub APIs, resource binding and triggers APIs, this really specialized programming model called actors, which we don't have enough time to get into. But it basically allows you to spread out millions of compute units, which are much more granular than containers. So think about, like an IoT system where each device is a granular compute unit. And so Dapper can actually host millions of these in a single Kubernetes pod, for example, and then fail them over if they fail with their state. So that's actors for you. So Dapper is meeting developers on a much higher level of abstraction than service meshes.
Got it. Okay.
And just going on with the community update. So the CNCF released this project velocity report end of 2021, and we've been really happy with what we've seen. So it's a little bit problematic to see where Dapper is, but it's right over my cursor here, right above Prometheus. Like I said, we've been seeing some awesome growth. And the y-axis here measures the number of PRs and issues. The x-axis measures the number of overall commits. And the size of the bubbles is basically governed by the number of distinct authors. Author meaning someone who opens either an issue or a PR in the project. So upcoming for Dapper 1.7, we're looking at two really awesome features: resiliency policies and component metrics, or extended component metrics. What are resiliency policies? Today, for example, if we were talking about service mesh, if you have one app, the one on the left here calling the other app, which is the one on the right, you might want to put retry policies and circuit breakers to ensure that you don't overload the other app, or that the calling app will basically reach another instance in the load balancing ring if one instance is actually not available, or if it's performing below expectations. But what service meshes don't give you in that sense is the ability to put retries and circuit breakers on your entire system. So your app naturally, most of the time, won't be just composed of one app calling the other. You'll probably have databases and caches and configuration stores and secret stores and message buses and queues. So in 1.7, using Dapper, you'll be able to apply global retries and circuit breakers across your entire infrastructure, which means that you'll be able to cover not only apps with retry policies, but essentially all of your infrastructure to make sure that it's reliable, that it's in place, and that, for example, if your database is becoming problematic, that you know, if it has higher latencies or if it's exhibiting increased error rates, that one app isn't actually overloading it and actually causing a different app in your architecture to suffer because it, for example, reads records from the database that's becoming slow due to another application's write. And that same problem can be applied to message buses and queues and caches and basically anything that your application interacts with. And the second feature that we're coming out with is component metrics. So today, Dapper emits open telemetry metrics. So you can see the number of requests per second, the latency and error rates when one app is calling the other. But we're extending that to PubSub and bindings and all of the infrastructure pieces that I talked to before. So if you use Dapper, you'll be able to get very rich telemetry, not only about how your apps are behaving, but about your infrastructure too. So for example, you might be able to put, you know, machine learning model in place, and using Dapper, you'll be able to go like, hey, I actually see that my database started to become slow. I want you to detect anomalies for me. That's a very sophisticated use case, but you could also just put alerts if your database becomes slow, or if you're getting more requests per second than you initially wanted for your bindings, you can scale that out or scale your infrastructure out. And so Dapper really takes this holistic view of not only looking at metrics for your application, but also across your entire infrastructure. And with that, I think I'm done with the maintainers update. So if there's any more questions, I can take them now.
We have one more, Yaron. Thank you so much. This is very comprehensive and helpful. The question from Sundar is, how does Dapper compare to Temporal? Through Temporal, or the Temporal is built as a workflow engine, it could be used to build distributed applications. I don't know much about Temporal, so please let us know.
Yes, I know about Temporal because we're backed by the same venture capital firm. No, not just because of that. Maxime and some are good friends. So Temporal are focused on workflow orchestration, right? So that's a stateful workflow orchestration where you have basically a workflow. You go, hey, Temporal, I have one app that now provisions something called an activity, and once that activity completes, you can invoke a different activity, and if one of my apps fail, then you can start off from where it failed. So it allows you to write workflows really easily. You can write workflows with Dapper, for example, with Dapper actors, but workflows and orchestration of workflows is not what Dapper today, at least, is about. Dapper's nearest building block, I think, would be the state management. And the state management API today is focused on key value pairs. So if you're writing anything like a shopping cart app that is stateless inherently but wants to store its state, Dapper will give you a pretty easy way to do that and abstract over multiple backend stores. Right, Temporal is about workflow orchestration, and the component model is not really something that Temporal does. So for example, if you're deploying your app to AWS and GCP, you can actually write once to the Dapper API, and then an operator can configure Dapper to work with Google Cloud Storage in Google Cloud or DynamoDB in AWS, and then you write your code once, you deploy your app to 2 different platforms, and your code doesn't change. So these types of abstractions, both for state and all of the other PubSub mechanisms, are also not something that the Temporal project does. It focuses really, really well, by the way, on workflow orchestration. And just to close in on that, we've actually in the Dapper community received asks about whether or not Dapper can be used from Temporal, and the answer is yes, because Dapper sidecars can be deployed in your compute environment. You can deploy the Temporal server, you can deploy the Dapper sidecar, and you can actually call the Dapper sidecar from Temporal activities, which I think is really 2 awesome technologies working together to give you this holistic solution in place. We might actually be showing that off in one of our next Dapper community calls. We have a Dapper community call every 2 weeks on a Tuesday.
Amazing. Yaron, thank you so much. A bunch of really, really great information. I think for everybody on the line, any further questions, all of Yaron's, whether it's the Twitter machine, LinkedIn, and so on, are listed on the meetup. Please reach out. Open source is great. So if you're not already involved, get involved. If you are involved, you know what to do. There are also other great Dapper. So if you go to the CNCF, you can see some of the stats that he was talking about. You can also see from KubeCon in October, Donovan Brown and Jessica Dean, some former colleagues of Yaron's at Microsoft, go over Microsoft's Made Easy, leveraging Dapper and Kubernetes Cloud Connector, I believe. Really, really interesting video. Please engage. Dapper is very, very interesting. Something I've voiced a number of times internally at my own firm. It's literally standing on the shoulders of giants. You don't have to solve it all. All right, so Todd Ekenstam, we're going to move on to him. Todd is a very well-established author. If you've seen the O'Reilly book, GitOps, he is a co-author of that with some other folks at Intuit and formerly at Intuit. He's also blogged extensively and had done a few presentations, whether it's GitOpsCon or otherwise. He is a, pardon me, voice getting a little dry. Sorry about that. So he is an employee at Intuit, and he is going to be talking to us today about Kubernetes at scale with security in mind, and telling us about all the great scale that Intuit has realized given their adoption of Kubernetes and cloud native over the past number of years, and the many clients that they support, and given the uniqueness of their business, right? All of us right now in the US are in tax season. So if you don't have an accountant, you're probably using TurboTax, and they've got upwards of 60 million, Todd, something like that. So yeah. Scale is a big deal to them, and scenario analysis and all the things that Kubernetes can help provide from a application deployment platform, but also the ability to just scale generally. Todd, the floor is yours. Please take it away.
Great. Thanks for that introduction. Appreciate it. Can you all see my screen?
Yes.
Okay, awesome. Great. Yeah, thanks. First, so I'll be talking about what we're doing with Kubernetes at Intuit, and also how we're looking to build an application-centric platform on top of Kubernetes. So first, a little bit about me. I'm a part of a platform team at Intuit that's building a multi-tenant Kubernetes platform. And this platform is supporting all of the applications that Intuit provides, whether it be TurboTax, Mint, QuickBooks Online. So yeah, if you're filing your taxes this year with TurboTax, you're actually using Kubernetes behind the scenes. Also a co-author of the book GitOps and Kubernetes. So if you're interested about learning more about GitOps, feel free to check that book out as well. And you can find me on LinkedIn.
Hey, Todd, real quick, do we want
Yes.
to mention the 35% discount on your book?
Oh, yes. So the publisher Manning is providing a 35% discount on the book. So I'll have the code at the end of the slide. Feel free to jot down that code if you're interested to get a 35% discount. I think it's actually good on any Manning book. Yeah, thanks, Josh.
And one more, Todd, and we're giving away 2 ebooks today for free, right?
Yes, yes.
Two ebooks for free for, let's figure out how to do this. So whoever asks kind of the most engaging questions, the best questions, I will be the judge of who that is. So who's ever kind of the most engaged on the Q&A box will get a free GitOps and Kubernetes ebook, and we'll send that to you today. All right.
Cool. Awesome. Yeah, that's great. Thanks, Josh. And yeah, hopefully that doesn't mean that there's going to be an onslaught of super challenging questions. So give me some softball ones also. So here's the agenda. We're going to talk about Kubernetes at Intuit. We're going to talk about what exactly is an application-centric platform. Then we'll go into the open application model, or OAM, and KubeVela, both of which are open source projects. And I'll give a KubeVela demonstration, and then we'll open it up for general Q&A and discussion. But feel free to pop in a question as we're going along in the Q&A box. I'll be watching that as we go. All right, so first, Kubernetes at Intuit. You know, we're a very big end user of Kubernetes and you know, public cloud in general. We developed Argo CD and contributed that to the CNCF. Argo CD has had phenomenal response, and it's really nice to see such a community building up around Argo CD. And related to Argo CD, we're really using it day in, day out inside of Intuit to deploy all of our applications to Kubernetes. And we're using the GitOps model at a very large scale here at Intuit. We're also the winner of the 2019 CNCF End User Award. You can see there Ed Lee, one of our distinguished engineers, or actually he's a fellow now, I believe, accepting that award. On the right-hand side, you can see kind of the scale that we're talking about. We have over 11,000 applications or services running on Kubernetes. We're managing over 250 clusters that kind of are using over 15,000 nodes on the back end. And I'm sure these numbers are kind of out of date by now, but that gives you a sense of the scope. But that didn't happen overnight. We've been on a cloud native journey for a while. So Intuit started out like most enterprises with a private on-premise data center. Then we migrated to AWS in sometime in the 2014, between 2014 2017 timeframe. And then in 2018, we migrated to Kubernetes, and we built a platform called the Intuit Kubernetes Service, which the shorthand is IKS. And the first iteration of that was a COPS-based Kubernetes cluster running on AWS. And then since in 2020, we migrated to IKS 2.0, which is an EKS-based cluster. IKS in itself is a whole nother talk, but IKS really is our platform for building security and Intuit best practices into all the clusters that we manage and provision out for use. So let's look at the developer experience. So we really wanted to make it easy for developers to consume Kubernetes and deploy apps on Kubernetes. And so we have what's called a developer portal. That's our own internal service at Intuit. And a application team can create a new service on Dev Portal, and that will provision out sort of boilerplate code, boilerplate deployment templates, and that all encapsulating all the best practices and security that we want for a standard service. And they can have that environment up and running in a Kubernetes cluster in under 10 minutes, which is a huge accomplishment for us, and really allows our developers to innovate quickly and create new services and not really be bottlenecked by needing to set up infrastructure. Once that's set up, they can continue to do what they want to do with releasing new code, implementing features, customizing the runtime, and then deploy that out to the managed namespaces. So to do this, we've developed a few open source tools. Argo CD is probably one of the most well-known. We also have Keiko Proj, which is all about different projects related to running Kubernetes on AWS at a large scale. And then we have Admiral for service mesh. I mentioned about the multi-tenant clusters. And so our approach is to provide multi-tenant clusters where each developer, each development team is a tenant on that cluster. And they're provisioned with these managed namespaces, which gives them a kind of a sandbox to work in and defines their permission boundaries. And we have what we call paved roads that allow different application types to be deployed into those managed namespaces. And each of those paved roads can then be managed independently by the application team. Our team, the central platform team, manages different customized remote bases that's used by those deployments and vended out to those application teams, which then the application teams can customize with overrides and things that are specific to their application, and then deploy to the namespace using Argo CD and using a GitOps model. We also want to enhance and continue to innovate on the platform side, and so we may send out periodic PRs to the application teams to integrate new features, adopt new best practices, things like that, to the application teams. But at the end of the day, the application team is really responsible for the DevOps operation of their managed namespace. That's really how we've defined it here at Intuit. So with that, we've been pretty successful. We've got a lot of positive feedback from our users, which are other Intuit developers. And one of the big things that they like is less infrastructure management on their side compared to when they were doing DevOps on low-level EC2 instances in AWS. So there's no AMI patching. And we also provide automatic base container patching, so they get that infrastructure management as well as enhanced security. There's automatic support for metrics and application scaling based on those metrics, which they also really like. A lot of the observability features come standard in our platform with application tracing, monitoring, logging, things like that. And of course, security and compliance is built in. We have a lot of systems to ensure security and keeping up with best practices. But then at the same time, they're provided this flexibility to customize their Kubernetes environment as the need for their application, which that turns out to be a little bit of a double-edged sword, right? It's great to provide that flexibility, but then maybe that flexibility is not needed by all teams. And we'll talk more about that a little bit later. So what are some opportunities for improvement that we've seen? One thing is, we talked about those PRs and updating the environment. That's good. It's great that we can do that. But whenever a developer has to take in that PR, they have to test it. They have to think about it. And they'd rather that be sort of done behind the scenes, right? So that's one of the things when we talk later, we'll be mentioning how we can abstract those kinds of changes away from the application and have it kind of happen automatically behind the scenes. We also have teams that would like to extend our Kubernetes platform and build other platforms on top of our platform. And again, that's a whole nother talk in itself. But another common theme is they want more self-service. They want to be able to access their cloud resources, automatically or in a self-service manner. And so, part of this application-centric platform is how can we provide easier access to those types of resources. So with that in mind, what exactly is an application-centric platform? What does that even mean? So first, let's start by looking at a simple web service. So with Kubernetes, this is kind of this is an example of what our environment might look like at Intuit, where we have a managed namespace. There's other things here, like resource quotas and other things that the application team doesn't need to worry about. But what I'm representing here is all the things that the application team would be responsible for. So of course we have a pod, right? But usually pods by themselves are not that interesting. You need to have a replica set, you need multiple pods, and you need some way to manage the life cycle of those pods. Then if you have multiple pods, you want to maybe scale those in some intelligent way. So you need to understand scaling policies. And then your application is probably going to need some configuration information, some secrets, some roles, and maybe a service account to access other resources in the cluster or outside the cluster. And then this is a web service. You need a service to allow network traffic to come into your pods. And then you need an ingress to allow traffic from outside the cluster to come in. So when you start thinking of from a Java developer standpoint, this is actually a lot of Kubernetes to have to understand, right? This is suddenly a simple web service application isn't so simple. And if you're dealing with all this Kubernetes, that's just extra overhead that application developers need to worry about. So what can we do? So, with DevOps, all these development teams are really expected to understand how these resources work and are able to update and modify them going forward as needed. And that's some kind of overhead and friction for these development teams.
So Todd, let's take
Yes.
a breather for a second here. And Mike, I
Yes.
think we got a question in the chat box there.
Okay.
And Shri, do you have a question? Shri J, you're on mute. All right, 3, 2, 1. Okay, back to mute.
Okay. All right, cool. Yeah, if you have a question, feel free to put it in the Q&A box. All right, so with that in mind, so what would we want out of an app-centric Kubernetes platform? Really, we want to focus on the developer experience, right? At the end of the day, we want the developers to be able to write their code, write their functionality, deploy that to their customers, and operate it safely and efficiently. So we want to focus on the developer experience. We want to reduce friction when delivering those new applications or features. And overall, we want the developers to really focus on the needs of their application, not on the needs of the platform. So how can we expose a model where you're really describing things in terms of the application itself, not the underlying infrastructure or the lower level Kubernetes constructs. So that's really what, when we're talking about an application-centric platform, that's what we're talking about. And so with that in mind, there are application-centric platforms emerging, right? We have, we've been talking to industry peers, and a common thread is that a lot of companies are developing their own sort of custom solutions for this problem. Each might be tailored to their own use cases. We also see a lot of work in the community. Dapper is a higher level development abstraction. Is there something corresponding that we can do on the infrastructure side? There's a project called KubeVela that's open source, but also mainly backed by Alibaba, that allows you to have a similar application specification that I just described. And Knative is applying to the CNCF. There's other, there's other projects coming out from vendors that allow this kind of application-centric platform. But what I wanted to do was kind of take a step back and think, okay, going back to a blank slate with, what would I want, right? What would we want to able to allow developers to define their application in what we would call an application-centric way, right? And this is what I came up with, where you might have an application that has multiple components, and those components might have different aspects to their that you can customize and modify. And in this case, we're showing different traits for each component. And the traits might be, for example, auto scaling based on some SLO that the application has. You don't really want to think about in terms of replicas, right? That's really a little bit meaningless from an application perspective. You may just want your application to maintain a certain service level agreement or service level objective. And so this is showing how you might define TP95 of 350 milliseconds or less. But then you might have a different component that has different requirements where you want to scale based on queue depth, right? And a lot of these are application properties, not properties of the infrastructure itself.
Hey, Todd, on that real
Yes.
quick, before we dive, I think this is great, by the way. I'm keenly interested to hear, especially as it relates to SLOs or SLAs with your SLOs. We have got a couple questions as it relates to infrastructure. So before we go up a level to the application-centric, Manny has a question on when you have many multi-tenant clusters, how do you make sure clusters are scaled to support workloads? How do you do capacity planning for these multi-tenant clusters?
Yeah, that's a good question. So first of all, we have the cluster autoscaler that is running and provisioning new nodes as needed, for the cluster. And we have a concept of different instance groups or different node groups. So we have a shared node group that is common to all the tenants on the cluster, but then also different tenants can have their own node group that's specific to their application, and that node group can scale independently of any of the other node groups. That instance group can also have different properties, right? It can run a different type of instance, if it's memory optimized or CPU optimized, or maybe it needs a GPU processor. So that's how we address that, where we allow scaling. We simplify scaling in the general case with a shared node group, but then we also allow custom node groups. Then for capacity planning, we look at all those node groups as a whole, and we have a mechanism to see that the capacity is reaching some level and things like that, and can automatically adjust.
I think there's some follow-up questions here. I think is a hot topic a little bit. So there's another question from Santosh on visibility across and consistency across multi-tenant, multi-cloud environments. I don't know if you were talking about multi-cloud up front, but just doubling down on just talking about multi-tenancy. When you talk about these different node groups, when there's a common or a shared one and the other node groups are different, so a tenant onboards, they get their managed namespaces as you provided.
Mhm.
What is the process for getting a new node group? Say like the data have some data privacy requirements that say that only these workloads can work on these nodes and not on a shared node cluster. How do you guys manage that?
Well, we manage it at a couple different levels. One is, like you mentioned, we can have dedicated node groups for certain applications, but then we do have some applications that justify having their own cluster, right? Or we may have, we may isolate certain applications on certain clusters that have similar security and compliance requirements. And so while they may still be multi-tenant, they're multi-tenant with similar applications, perhaps from the same business unit or the same, the same development team, but running, co-located on the same cluster. And so that's how we partition and provide that isolation between between different development teams and different business units. It starts at the namespace level at the very basic, but we also scale that up and provide that isolation at the cluster level as well.
Okay. A couple more questions really quickly, and we'll time box it to 2 minutes so that we can get to the rest of your presentation. There's a couple as it relates to SLOs, uncontrolled requesting of resources. So is there an upper bound when you create these auto scale node groups? Okay.
So cluster auto scaling is one part of the equation. The other part of it is, HPA or KEDA or some other sort of pod scaling. And I think the question is, well, what if there's a bug that starts, an application is running away with CPU and just scaling up and up and up, or maybe it's a misconfiguration. So we do, in each of these managed namespaces, we provision quotas and resource limits within each namespace. And so that we're guaranteed that any particular namespace will not exceed that, that quota or that capacity that's been allocated to them. And that protects them from incurring unexpected cost if their application starts running away. And it also protects other applications on that same cluster from kind of that noisy neighbor situation. So yeah, that's our main control. And these things are provisioned to the namespace where the tenants cannot change those attributes of their namespace, independently. It has to be managed and go through some controls. Got it. Okay. One more before we go on to the rest of the presentation at the infrastructure level. So the in-depth end-to-end governance in the multi-tenant, multi-cluster environment. So how does Intuit solve for, at the infrastructure level, the soft and hard tenancy? So hard tenancy being network isolation, single cluster, and then soft isolation within the cluster from an ingress and egress perspective from the namespaces. Yeah, so we have, there's two different approaches we have. Right now we have what's called our API gateway, which is an Intuit product for managing, it's our own internal product for managing access between different services. And that API gateway enforces a lot of our security and controls between applications, and also external access from, say, for example, websites or mobile applications. So that's one level. Then in addition to that, we're using service mesh to facilitate traffic between services inside the cluster and also between clusters, and that's all controlled. That's controlled through the service mesh. We have that's Admiral specifically, right? So use Admiral for your cross-cluster service mesh communication. Yeah, that's so Admiral is kind of an extension to Istio to manage, to make it easier to manage multiple clusters. Yeah. Awesome. All right. So then we also have at a low, way lower level, we have a network segmentation in our VPCs, and we have things placed on different networks and things like that give us sort of the low level network partitioning, at the very lowest level. So at the infrastructure, virtual infrastructure layer, before you stamp out a Kubernetes cluster, you still have the same tricks of the trade, the network isolation, the edge, the boundary devices, the network tables, everything you would use normally with whether it's VMs or otherwise. Correct. We have a separate ingress subnet. We have a separate node subnet. We have a separate pod subnet, and we have a separate egress subnet, and we have control over all the routing between those. Awesome. Yeah. Very helpful.
Awesome. All right. Todd, I have to jump in. Sorry, guys. So I need to give an update on the free book, the free ebook, GitOps and Kubernetes. It is a horse race between Santosh, Slavomir, and Mani. If I'm saying that
awesome.
Right.
Awesome.
Yeah, so it's neck and neck.
Yeah, thanks for all the questions. Yeah, this is great. And this is the kind of thing that we really want to encourage on this meetup, is these kind of questions and conversations. So yeah, I appreciate it.
64 people in the room. Don't make it a 2-horse race if you want to book it. I've read it. It's exceptional. So definitely ask questions.
Yeah, appreciate it. So then, okay, let's go on with the presentation. So, this is how we're viewing this. At the end of the day, we want these developers to really focus on their application code, focus on their business logic, and adding value to Intuit's business, through increased features and things like that. And by allowing them to define what their application needs, through this application definition, and then having platform components that translates that into what that representation should be at a lower Kubernetes level, we think we'll get a variety of benefits from that. First, since the applications are abstracted from Kubernetes, there'll be less need for migrations. One pain point for us is when Kubernetes deprecates an API version of some old API. For example, I think in 1.22 there's some changes to PDBs, and there's also change to ingress that's coming up. And so whenever this happens, we need to update all of our deployments to use the new APIs instead of the deprecated APIs. And if we've abstracted that away, that will ease that burden. Also, with the simplicity, you can, developers don't need to worry so much about the lower level details. They can focus really on their application. That's a little bit of a double-edged sword, because with simplicity, they may not fully understand how their application is running. And so you need to pair simplicity with really good debuggability and diagnostic features. Because at the end of the day, the application teams still need to know how to debug and run their applications. We think this will also give us more velocity, allow developers to, deploy faster and more often, and utilize, different configurations that are offered by the platform. Yes, so there's a question in case we'd like to move away from Helm. So in case I would like to move from Helm, can it be automated or rewrite the YAMLs? So yeah, so you may want to think, how can you encapsulate your Helm charts in a way that that provide that same functionality, but in a way that's easier to manage. And I think I'll talk about that a little bit later in the presentation. Okay, so with that, let's think. So we've at Intuit, we've looked at a few different technologies. One that caught our eye is the open application model in KubeVela. I should be clear, we're not using this day to day right now. That we're still investigating this technology. But it looks promising for this use case that we're, where we want to provide an application-centric platform. So what exactly is OAM in KubeVela? So it's an open source engine that runs on top of Kubernetes, and KubeVela is an implementation of OAM and allows an OAM application specification to be translated into Kubernetes primitives. It's really designed for platform and operations teams to create that, create these developer-facing abstractions on top of Kubernetes. And so, to answer the question about Helm, KubeVela also supports exposing a application definition based on Helm charts underneath. You may still have, some challenges maintaining those Helm charts, but then at least from the developer perspective, they're using a common application definition. It also hides from the developers a lot of the complexity of configuring Kubernetes manifests, such as scaling policies and deployment strategies. And it's not that, if you look at Kubernetes YAML, pretty much every line in the Kubernetes YAML is actually needed, right? You need to be able to, there's not a lot of fat necessarily in the Kubernetes YAMLs. What it is for your use case, are you ever really going to configure it a certain way, right? If you have a web service, it's going to fall into a certain set of patterns, right? Or if you have a task, you're going to have another set of patterns. And so by taking away this complexity, you're able to provide, defaults and common behavior for your use case, instead of, Kubernetes by necessity has to almost support all use cases. And then, so KubeVela is really a tool for platform teams, I think, to define these kinds of abstractions based on their organizational policies and best practices and things like that. It says here adopted by, I'm not sure, maybe adopted is too strong of a word for Microsoft, but I know that there's been some public talks by Microsoft about OAM and its precursor Rudder, and KubeVela's precursor Rudder. And also I know KubeVela is used pretty actively as part of Alibaba's cloud offering.
Microsoft initially submitted the spec to the CNCF, and Alibaba kind of took it from there.
Yeah.
From like the core sponsorship perspective. I think Microsoft's still involved. Again, those CNCF stats are available on the dashboard. If anybody's interested from the CNCF side, they can see who's contributing to what, but it's a good model in general because it does abstract those, right?
Yeah.
Kubernetes is great. It's got a few leaky abstractions, and for the average enterprise developer who's trying to ship code, not containers, it can be a little overwhelming. OAM is something that helps alleviate some of that pain.
Yeah.
Albeit
exactly.
not tax-free.
Yes. Yeah. Nothing comes for free. But yeah, so with that in mind, let's take a look at OAM. So this is maybe this is a little bit oversimplifying OAM a little bit, but the basic idea is that OAM allows you to define components and then traits. And then a trait is something that can be applied to a component and can modify that component's behavior. And then once you have these components and traits defined, they can be aggregated to define your application. So, like what we were talking about earlier, that application is, you can view an application as being composed of multiple components, multiple traits, and that's really what your application is at the end of the day. And then the open application model is a common specification, and you can submit that to some OAM implementation that translates that to your actual infrastructure, whatever you're running. And so in our case for Kubernetes, KubeVela is that OAM implementation that takes that OAM specification and does the right thing for Kubernetes. There could theoretically be other OAM implementations for other cloud providers, or maybe whatever the next thing is after Kubernetes. You could write a OAM implementation for that. But the promise or the idea of OAM is that your application specification wouldn't need to change in those cases, right? The things that how you're defining your application, unless the needs of your application change, there shouldn't be a need to change that going forward.
It's a really good delineation. Go ahead, Josh. Sorry.
Oh, no problem. I was just going to say there's a question from Chakri, and Chakri, step up if I'm not. But it says how to support GitOps kind of model with KubeVela.
Mm-hmm. So I had a few slides on that. I took them out, unfortunately, but I can talk to it real briefly. So there's a few things. One is you can use a tool like Argo CD to submit these OAM specifications to the target client, or to the target cluster, excuse me. And then the KubeVela is an operator that's running in that cluster that would then interpret that spec, because you can express these open application models in terms of a Kubernetes type specification. And actually, maybe I can go there here. So here's an example of an OAM spec, and notice it looks like a normal Kubernetes spec, right? It has an API version, it has a kind, and so you can use Argo CD or a similar tool to submit this type of specification to your cluster, and then the KubeVela operator would be looking for this resource, looking for all the application resources, and then operate on those. So that's one way. The other, there's some more sophisticated integration points where you can actually have KubeVela output and write the rendered Kubernetes manifest, the lower level Kubernetes manifests to a GitHub repo. And then by rendering it to that GitHub repo, that would trigger the GitOps process, and you can manage it, normally. So there's a few different mechanisms for integrating that. And what I'll do is I'll put those slides back in and see if I can send those out after the talk.
So KubeVela, given this is a good point. And what I was going to state before is that the CNCF doesn't just have application implementations, but it also has specifications, right? Another Argo project that's very popular, Argo Events, is based off of the Cloud Event Standard, and it's part of the Argo project broadly. So it's an implementation of that spec. This is the KubeVela is an implementation of the OAM spec, and
Exactly.
there can be others, but it's still Argo CD interprets apps or app sets, right? And does the appropriate thing when the controller intercepts that interaction at the cluster level, right? Same thing with KubeVela. There would be an operator or controller there that would intercept the abbreviated OEM spec here and do the appropriate actions based on that interpretation.
Yep.
We have a couple questions. Are you game for a couple, Todd?
Let me let's see. I might want to hold some, but let's see what we have here.
I think one relates to what you're showing right now. So Priyanka Tembi has asked, what would applications need to define an OEM spec, as they are the ones who understand the app? How to make sure that all app teams are on the same page about how to write these OEM specs?
Right. Yeah. So what we'll see is, I think there's a platform team or an operations team that might be defining what these components are, right? And so what does it mean in your organization? What does it mean to run a web service? What are some things that you want for all web services? And then, yes, then I think the application team would then consume that component to say, okay, I want to create my own web service. And of course, that development team is going to know what image to use, and they may have some other requirements of what traits do they need to apply for their specific application. So yeah, definitely, I think the ownership of this application spec would be in the hands of the development teams themselves, but the definition of these components and traits is more of think of them as a library of options or a menu of options that the development teams can utilize, and that can be evolved and improved over time by a more specialized platform or operations team.
Cool. Hey, Todd, I want to step in real quick just to let everybody know we have scheduled an hour and a half for this meetup, so feel free to stick around. We still got a strong audience here for you, Todd. So I just want to let everybody know, if you have some more questions, you want to ask some questions, we have plenty of time to do that. Also, I want to give an update on the free GitOps and Kubernetes ebook. We have Slavomir is number one in front by a nose. We have second place, we have Tide Santosh Amani, third Sundar N, fourth Kanuka, if I'm saying that correctly. So that's where we're at right now.
Cool. Awesome. All right. So to get back to the presentation, KubeVela has different components and traits sort of out of the box, so to speak. And so these come as part of the KubeVela installation. But this gives you kind of a sense of what exactly are components and traits, right? You have a task component, you have a web service component, or a web server, or a worker component. And then on the trait side, you have annotations, config map, labels, node affinity, scalar, sidecar, and there's a lot of others. This is an abbreviated list. But really, the cool thing for me as a member of a platform team is that you can write your own components and you can define your own traits. You're not limited by whatever KubeVela is providing, sort of out of the box. And that's, for me, that's really where the power of OAM and KubeVela come into play. The other thing I would say is if you look at these traits, a lot of them start to look a little bit like leaky abstractions, right? Like, do you want to really have a trait called a sidecar? Is that like a very overly Kubernetes specific thing? Or like, so some of these traits, you have to really think about what exactly do I want to expose to development teams, right? And is it really exposing things at the right level? So that's something to look at as we go forward with with this technology. All right, so now I'm ready for the live demo aspect of this. Let me switch gears. And so let's look at how KubeVela actually works under the covers. So let me start by bringing up KubeVela. KubeVela has a UI called Vela UX, and it gives you this web interface. So let me just create a new application just to kind of demo how that works at a high level. So here, let's call this my web service, and I'm going to use a container or a container image. This is my all right. And I'm going to bind to the default environment. KubeVela lets you define multiple environments, and it really does a lot. I looked at KubeVela maybe 9 months ago, and in the last 9 months, they've really expanded the scope of KubeVela quite a bit. That's a little bit tricky because it's a little bit difficult to understand where can you integrate this with the other things that you're doing, because KubeVela is really at least the KubeVela UI is really trying to give you an end-to-end experience for deploying applications. And at least for us at Intuit, that might not be what we want. But here I'm specifying the image. You'll notice it's exposing some other properties and some configuration that I can set. And again, a lot of this is a little leaky, a little bit low level, but perhaps necessary. But now I'm going to go and create this application, and now I'm going to deploy this application. And let's see, then it's going to give me a green icon here when it's done.
Todd, real quick,
Yes.
just contextually, objective, yes or no is fine. So for the GitOps inclined, everything you went through the imperative UI driven buttons are not going to commit anything to a Git source code repository and create anything that is reproducible. If this application, these pods die, all this state is gone.
Yeah, no, I think KubeVela maintains its own state. So
Okay.
So there's a whole, that's honestly an open question for me, right? And someone asked it earlier, how does KubeVela integrate with GitOps? And I think it's possible. I don't know that I've seen it. I haven't really seen it be done for myself. So I think there are some open questions, and at least for myself, I still have some learnings to do on that. This is all maintained. KubeVela maintains state inside the cluster using config maps and other things, so that I think this would be persistent, over time. But what at least what I would really like from an Intuit perspective is to be able to do all this, what I'm showing you, using Argo CD, for example.
Here.
So now let me switch over to my command line. If I do kubectl git pods, actually just do a git all. Sorry. you'll see that I've deployed my web service, and it's created a deployment, it's created a replica set, and it's created a pod, right? So there, that's the application that I created using KubeVela. But what if my needs are different, right? This is the web service that was defined by KubeVela, but it may not be exactly what I want. For example, if I look at this, if I look here, all and PDB, I don't, there's not a service, there's not a PDB. There might be some things that are missing from what this web service is. So now we're going to do, this is a little bit advanced KubeVela. We're going to create our own custom component. And I'm going to start with a normal Kubernetes manifest. This is a normal deployment manifest. It has a deployment, it has a service, and it has a pod disruption budget. And I'm going to run a command to called vela def init. And I'm going to pass it a few parameters. And one of the parameters is this template that I'm looking at on my screen right now. And I'm going to pass it that template. And what it's going to do is create kind of a starting point for a custom component. So this is going to create this file called cloudnative.q. And Q is a programming language that's really useful for templating. And that's one of the key, or that's one of the main technologies that KubeVela uses, is this Q language. And you'll notice it vents me out some metadata. This part is really all about the component itself. And then the template is how the Kubernetes template should behave underneath. So first I'm going to take this stuff out that doesn't, I don't need that there. And if I save this, I'm going to save this file. And I'm going to apply it to my cluster. Now, if I switch back and I create a new application, you'll see that there's a new type here called Cloud Native, right? This is the component that I just deployed, right? But there's some problems with this component. First of all, it's if you look at it, a lot of the names are all hard-coded and things like that. So the name is hard-coded to be hello world and things like that. So I'm going to parameterize this. And these are some variables that are injected and available as part of KubeVela. So I'm going to change the name to context name. And basically everywhere I see hello world, I'm going to put context name. And then here, I'm going to call this PDB, and I'm going to call this context name, and I'm going to call this service, and then I'm going to call this context name, and then this is context name. Let's see, did I miss any? This is context name. Okay. So this is starting to be an actual component that I could use. So then now that I've done this, I can apply it again, and it submits that new definition of this component to the cluster. But there's a few other things that are still hard-coded. So right now, for example, the image is hard-coded. Well, that doesn't really make sense, because if I have a reusable component, I'll probably want it to use different images. So what I'm going to do is add image as a parameter to this component. And the syntax that it uses is you can provide a default using the asterisk provides the default, and then you can provide the type of the parameter like that. So now I've defined this. If I go back and change my deployment, I can change this to parameter.image. Then I might also want to allow the number of replicas to be changed. So maybe I'll change this to parameter.replicas and put replicas down here and see replicas. We'll give it a default of 1 and it's an integer. Now replicas, yeah, so then we have that. And so let's save that. And before I deploy it, I'm going to refresh and then create a new application. And I'll call it my demo app. And I'm going to choose the type cloud native and deploy it to the default environment. And notice on this page, there's no options, right? Because this is the older definition of the component. There's no parameters in that earlier version. I'll go ahead and create the application and deploy it using that earlier definition. And I can go back and see if I edit the component, edit the properties of that component, there's no parameters. But now if I go back and deploy the new updated definition of the component, I can create a new application. My demo app 2, and I'm going to choose the cloud native and send it to the default environment. And you'll notice I have those parameters. So it's relatively easy to create these custom components, and then using KubeVela to deploy applications based on those custom components. And what we're showing is a very simplistic example, but you can start to understand how you can encapsulate more complex infrastructure in these components and abstract that complexity away from the application developers. And that's all I had for the demo.
Todd, we have a couple questions, and Sundar and Slavomir and Mani, they're really going for the top spot.
Yeah, I was afraid of this. I don't know how this is going to work out here.
Yeah, they're really going for it. So we have 2 free books. Maybe Todd, I'm going to have to request a third one, but we'll decide at the very end.
Okay.
So I don't know if you want to take those questions in the Q&A box at this time.
Sure. Yeah. So thanks, everyone. Appreciate it. And I'll try to go through as many questions as I can, but that's pretty much what I had to present today. I appreciate the opportunity and also appreciate everyone's time to come join. Let's see. So yeah, first question is, how do you support GitOps model with KubeVela? We talked a little bit about that. Oh, I'm sorry, that's the chat. Let me switch to the Q&A.
Todd, on that note, there is a GitOps section in the documentation for KubeVela. So they do have a pattern for it. Not sure how well it matches with like a pure Argo CD GitOps driven control plane, but food for thought for those.
Yeah, there was a CNCF blog from the KubeVela team about using KubeVela with Argo. So check out that blog. I think there's some, at least in my mind, there's still some open questions, and to really make sure that we're integrating the best we can between KubeVela and Argo CD. And also, I think KubeVela has changed significantly since that CNCF blog was authored, but yeah, that would be a good place to start. Like I was mentioning, there's a few different ways you could integrate with GitOps. you could use GitOps to manage your application specifications themselves, and then use GitOps to submit those to your target cluster. And then in the target cluster, the KubeVela operator would be running and would create all the underlying Kubernetes things, as needed. If you wanted to pre-render those Kubernetes resources, I think there's a capability in KubeVela to have an action that basically in the pipeline of KubeVela to export those rendered manifests back to a GitHub repo. And so that might be another integration point if you wanted to actually track the lower level Kubernetes manifests in GitHub.
Todd, on that real quick, before you go to the next question, I know Josh had requested, we've got 12 minutes left, make it conversational. Why is that important? Rendering out the templated form from a manifest or a template or so on.
So there's a few important considerations. One is if you think about a pipeline, at least at Intuit, we have deployment pipelines where you start in a dev environment, and then you go to an E2E environment, and then you go to a staging or maybe a performance testing environment, and then a staging environment, and then you have production. And so you have this pipeline, and you're deploying your application through this pipeline. What happens if you're halfway through that pipeline, and just like I did in the demo, I deployed one version of the abstraction or one version of the component, and then I created a application using that version of the component, and then now I want to update the definition of that component to be slightly different. I want to be careful that I send that change all the way through my pipeline, starting from the beginning, right? And so being able to commit back the lower level rendered Kubernetes manifest back to your GitOps repo would be one way to ensure that those, that exact set of Kubernetes manifests went all the way through your pipeline and were fully tested, by your process. If you change that midstream, then you might, like, say you're about to deploy to prod, and then the platform team upgrades the component for KubeVela, and then that's rendered sort of on demand and pushed out to prod. You could have infrastructure being deployed to prod that hadn't been tested in your earlier environments.
Awesome, thanks. Yeah, one thing we've seen at BlackRock is when you don't pipe out the actual form, the low level form, it's really hard to do 4 eyes review and PRs too, to notice what has changed. So if it's a remote base with just a tag difference, then like not all the IDEs have really good click through creature features to find out what actually changed in any of those underlying, whether it's customized bases or Helm values or upstream Helm charts or anything. So it's a really, really good call out. I wanted to make sure that we doubled down on it. All right, sorry, go ahead with the questions.
Yeah, no, that's a good point. Yeah, and being able to audit and see the exact literal changes version from version, that's another thing that, like you were mentioning, that's what you'd want to be able to do.
Highly regulated firms that we both work at,
Yes.
it's imperative and absolutely required.
Yeah.
Todd, I have a major announcement right now. Sundar has taken the lead for the free ebook.
Okay.
And they
Okay.
have at second place, Slavomir and Santosh are tied right now, neck and neck.
Yep.
Going down the home stretch.
Yeah.
Yeah. So Sundar, so let me ask, on that note, let me answer a question from Sundar. So KubeVela, he says KubeVela is still using the Kubernetes structure of metadata spec and spec details. Those details may change. And how does KubeVela abstract those? And so if we go back to this specification, what he's talking about is, maybe this is V1 beta 1, right? And what if this changes to V1 beta 2 or V1 or something like that? But the idea is that this is the open application model specification itself. And this is a very relatively simple specification. And the changes that I've seen to the specification are more additive than it is, making substantial changes. So in other words, I think they've added some additional properties in the spec beyond just components. There might be other things in the spec, but the spec is pretty simple. I have a list of components, and each component has a list of traits. And it's really the definition of those components and traits that's different. But with KubeVela, those differences are really configuration and data driven and not tied closely with this spec itself. That being said, there is a challenge if you look at there's a tendency to have a trait that's really tied to a low-level Kubernetes concept, like, for example, ingress. And then what about in Kubernetes 1. In Kubernetes 1.16, ingress changed significantly, and in 1.20 it changed significantly. So how do you provide an abstraction using KubeVela and using OAM that doesn't leak out those kinds of details to the application and to the developers, and allow you to make those changes independently, kind of behind the scenes? And that's what's challenging for
engage in the open source, right, Todd?
Like
get
engage in open
involved,
source,
right?
but I think when you create these traits and components, you really have to think not only about making it work, but making it maintainable long term, right?
Yeah. Ingress going to gateway API seems like a major change, where V1 beta would, like, from a domain architecture perspective, would probably necessitate like a V1 beta 2 or something like that, because these are CRDs under the hood and major changes.
Yeah, these are major changes to Kubernetes, but it shouldn't be a major change to the needs of the application, right? And so that's the whole point, is by having this application specification the way we have it, even though Kubernetes might be changing underneath, and this is also showing a very leaky abstraction, right? I'm showing Ketascaler. I'd rather not have a Ketascaler. I'd rather just have a scaler that does the right thing for me automatically under the hood, right? I don't want to, this is a kind of an example of that leaky abstraction that Sundar is talking about. So I wouldn't actually have a trait called this in my implementation. Any other questions that pop out?
Santosh is really going for it. He's really putting the pedal to the metal here. Did we answer that question, Mike?
I don't know. I think he's asked it twice now. So consistency and visibility across both multi-tenant architecture and federation and observability seems to be the base of the question.
Mm-hmm. Yeah, I don't think that KubeVela necessarily plays in that space. KubeVela does, like I mentioned, KubeVela is growing in its scope, and it's really trying to be a multi-cluster deployment orchestration system to allow you to deploy your applications to multiple clusters and multiple environments within those clusters. So KubeVela itself is addressing sort of like the multi-cluster, multi-environment question, but not really from the application perspective of federation and connectivity and observability. I think those are separate concerns from KubeVela.
Danuka is coming up, starting to make a move.
All right, so let's see, monitoring metrics of deployed microservices. I don't think KubeVela, again, monitors any metrics, but you would need to, as you're defining your applications and how your applications scale, you would want to build traits that consume those metrics for auto scaling purposes or other things. But I don't think KubeVela itself deals directly with metrics. So there's another, Manny was asking about blue, green, and canary deployments. I think you would, that's again, at Intuit, we use Argo CD and we also use Argo rollouts. And Argo rollouts allows for progressive delivery based on observed metrics and the health of your application and canary releases and different things. So I don't think that KubeVela itself is offering blue-green or canary deployments or things like that. But that's where I think we need to look and see how we can integrate this with other existing tools like Argo CD and Argo rollouts for that, or maybe Flagger, other similar technologies, and make sure that those can be integrated together instead of having that be a feature of KubeVela itself.
Cool, guys. I think we need to start wrapping this up, but I did have a quick non-technical question for you, Todd.
Sure.
The KubeVela core maintainers, I don't see them out kind of talking about the project. I think everyone's in China. Is that a concern for you at all, or?
That is a concern. Although I have to say I've engaged on there's a KubeVela Slack channel that I've engaged with folks, and I've gotten really good, very good and quick response. And that it does look like it is the KubeVela community is still in its early stages, I think. But I do see some additional interest and some additional activity. But it's still a little bit early, I think, in my mind.
Yeah, it's just not clear. What's going on with those guys.
Yeah, but yeah, I definitely encourage, if you're interested in this type of approach, check it out for yourself, engage in the KubeVela Slack channel, ask questions to get you unblocked. And so far I've seen them be very, very helpful and responsive.
Awesome. And so the winners are number one, Sundar and Slavomir. Slavomir, if I'm saying that correctly. I apologize if I'm mispronouncing your name. So you two will be getting a free book, ebook, and I'm trying to figure out how do I get your contact information. Sundar, Slavomir, I will drop my email in the chat there, and go ahead and reach out to me, or you can reach out to me also on Meetup. And so Joshua Hurst, everybody else, we'll send it out. I put it out earlier, but there's a 35% discount if you would like to get that book. I dropped our next event, the next event link. Please sign up for that. You're invited if you'd like to. And yeah, Mike, did you want to bring it home, or Todd, did you have any last thoughts?
Yeah, I'll turn it over to Mike. I appreciate it. Thanks for the opportunity.
Thank you.
Todd, thank you. I learned a ton. Yaron, again, thank you for the community update. I learned a ton. And one of the reasons I sounded like we had prepared for this, we probably didn't prepare as much as we wanted due to vacations and long holiday. I engaged deeply in the open source. I follow a lot of these projects that Yaron and Todd talked about today. We're active contributors to Argo CD. So I encourage everybody who's not already engaged in the open source. It's an open and friendly community. It just takes that first step before you take your second, and where you'll want to take your third, fourth, and fifth. The folks that you'll find, you'll extend your social network in a way that you wouldn't otherwise realize. And just to underwrite one final point from Todd's presentation and what Yaron was talking about too. Dapper, really good application runtime. It can help you a lot. Argo CD, KubeVela, Open Telemetry, all the things that we've mentioned. Once you decide that you're going to go cloud native, and kind of the rhetorical next questions are containers and Kubernetes for atomic deployments, single service, microservice, and then orchestration, you need a host of other tools. The CNCF has a great dashboard you can look at as a trail map. It really helps you along the way to figure out what the best tools are, or potentially the ones that fit best with your business and your business posture. But it's all in the open source. So engage, have fun, and reach out. I think everybody's socials are listed on the meetup, mine as well. Please reach out. I'd love to hear from anybody. I know Todd, Yaron, Josh, everybody else would as well. Thank you so much for your time today.
That's awesome. And thank you, Mike, for all your support and all the work that you, and you too, Todd, that you do for the open source community. It's quite extraordinary. And yeah, if the speakers don't mind, just, well, so goodbye, everybody. Hope to see you again. We do these on a bi-weekly basis. And like I said, I dropped the next event link in there. So please join us there. So speakers, stay with us. And Chase, are you there?
Yes, sir. I'm here. How you doing?
Doing great, doing great. So Todd and Mike, so Chase is, I think you're new to Kubernetes. I think one of the questions that you said, what's a great way to get started with Kubernetes, or a beginner type of book, and wanted to help you out with that.
Yes, sir. I would like to know, where do I start? Let me give you a little rundown of where I got in at. My friend, he lives in Denver, and he's pursuing is that rain? He's pursuing a associates in cybersecurity. And I stumbled on one of his, I guess, notepads, and it was going over a couple of, I guess, functions like, well, he deals with Python, so he was showing me about the scripts.
Make it quick, Chase.
Yes, sir. Yes, sir. So basically, the question I wanted to ask was, as far as if a person wanted to choose a career in, let's just say, IT or coding, where do a person begin? What literature do I need to pick up, or what would be the path I need to take?
Yeah, I think there's a lot of actually free online, training for Kubernetes and for, for Go programming, which is if you're interested in Kubernetes specifically, Go and